Today I'll be solving contains duplicate problem, NeetCode 217. Let's read the problem statement. Given an integer array nums, return true if any value appears at least twice in an array, and return false if every element is distinct. First, I would like to think about how would a dumb rock solve this. That is brute force. If I did not know any data structures and if I were solving this for the first time, I would just go through the list. 1, that's the example given here, and then I would keep note of what all I saw somehow. So when I see 1, I'll keep 1 in my memory. I'll just separate this and use common braces to denote my memory. And then whenever I see 2, and then let's say I saw 2, I'll go through my memory. I will see, hey, 2 does not exist here, and that means I haven't seen 2 before, and then I'm going to add it to my memory. And then when I approach 3, I'll look into my memory. I'll look at 1. Hey, is 1 is equal to the number that I'm seeing? Is 2 is equal to the number that I'm seeing? And then I'm going to, if I reach the end of the like data structure or my memory, that means I haven't seen this number before, so I'm going to add that. And when I reach the last number 1, I'll go to the first part of my memory and check, and yes, I've seen this before, and I'm going to return false. So let's talk about time complexity here. If n would denote the length of the given input, that is length of the given array, and I'm using, when I say memory, and I'm using all the functionalities of a list, I'm accessing every element. So let's say I use list as my supporting data structure for the memory. So I'm going to do n comparisons for the first given input, and whenever I see each element, I will be again doing x number of comparisons here and from the memory to see if I've already encountered the number before. So let's talk about how this extra memory would grow, and let's see if it was 1, 2, 3. If that was the given input, this is how my memory would look. So in the worst case, my extra memory would match the number of elements in the input array. So in the worst case, I'll have to compare each element, that is, let's say n elements in the input array with n elements in the memory. So it's going to be big O of n square, and it's going to look like for loop within for loop. So that's one way to tell that it's going to be big O of n square. And let's look at the test constraints here. It says the num's length will go up to 10 to the power of 5. That means this solution won't cut it. So where can we improve? So if you think about where we can improve, most probably the answer is we can use other data structures instead of list. So we have something called hash maps or dictionaries in Python specifically, which will give you constant lookups. So what I mean by constant lookups is, so let's say we have 1, 2, 3, 1 again. Let's take the same example. I'm going to add 1 whenever I encounter 1. I look into my data structure, And when I say it gives me constant lookups, right? So that means it take any, regardless of the size of the dictionary, it will take a constant amount of time for me to look into the dictionary and find out if an element exists or not. So I'll follow the same logic, but I'll just add dictionary instead of a list. So how this would work is, again, I'll add 1 because I haven't seen it before. I'll come to 2. I'll come to 2 here, and that's not in my dictionary, so I'm going to add it. I'll come to 3. I haven't seen it before because it's not in my dictionary. When I encounter 1, hey, it's in my dictionary. That means I'm going to return true because this contains duplicate. And let's again talk about time complexity here. And it's going to take, in the worst case, n amount of iterations to parse each and every element. Again, assuming that n is the input size. And when I say input size, I mean the number of elements in the array. That's the size of the input, which is a list of integers. Okay, coming back to the time complexity. So again, it's going to be n. So for when we access every element, how long does it take for me to find out whether it exists or not in my dictionary? So since I've used hash maps or dictionary, it's going to take a constant amount of time. So no matter if I have 1,000,000 elements here, this won't increase with the number of elements in my nums. It'll always take constant amount of time. So let's quickly code this up. Dictionary. So this is how you represent dictionary in Python. For I in range, okay, for num in nums, for each and every element in nums, I'm going to see if nums, that num is in my dictionary. If it is in my dictionary, that means I've already seen it before. Oh, you know what? I'll just change the name of my dictionary to scene. If not, then I'm going to add this number to scene. We can also use sets. That's another data structure that will guarantee constant lookups and maintains distinct elements. So let's say we reach the end of the input and still we haven't seen any number in our memory. That means this does not contain any duplicates, so we're going to return false. Let's run this. Okay, we are passing all the test cases, and yeah, oh, I beat 87%. Let's see what the 1.9% would look like. Oh, this is another smart way to do it. Again, I just talked about sets, right? You're getting the set of nums, which will just include the which will just include the distinct elements present in nums, and then you're comparing, hey, is the distinct elements length is equal to the length of the input array? If they are the same, then this does not contain any duplicates. This is one smart way to do it. Okay. Yeah, thanks for joining me.